Today we're looking at other types of equations. I chose a rather messy example. I figure that's what you really want to see, are the messy ones, so that you can do the easier ones. Now, we've got x to the 6 minus 64. We're going to attempt to factor this thing. It is a difference of squares. So in factoring differences of squares, I recall back from the deep recesses of my mind that that's going to be x cubed plus 8 and an x cubed minus 8. I put up here at the top, I put the formulas for the sum of cubes and the difference of cubes. You're going to need these. You'll want to put them on your note card if you don't have them memorized. The hardest part in doing this is to figure out what each thing cubed is. Obviously, A is going to be x. But for the B, you might think it would be 8, but it's not 8 because the B is whatever this number is. Something cubed is this number. So that would be a 2. X cubed plus 2 cubed. And that would give me my sum of perfect cubes. This one would be x cubed minus 2 cubed. And then I would use my formula. In this case, the sum of perfect cubes, A is x and B is 2. So I just use my formula. I plug in the x wherever I see an A, and I plug in a 2 wherever I see the B. So this will bust apart, and then this one will bust apart. And they're going to be quite messy. Wherever I see an x, wherever I see an A, I put an x, so it's going to be x plus, and B in this case is 2, so I'll put a 2 down. Then I need to square my A, so that would be x squared minus A times B, so that would be 2x plus B squared. Now B is 2, so that would be plus 4. That gets me, let's see, that gives me this little guy squared is sitting right here. Now the next one, let's put that in this color. The next one is this guy right here. I'm going to factor him and put his answers in this little slot right down here. So in this case again, A will be x and B will be 2, but I'll be using the difference formula. So wherever I see an A, I put an x, so it would be x minus 2, and then x squared plus 2x plus 4. Nice and easy. Now, I'm still not finished. I can read off 2 of these answers. I can tell in this case x is 2. That would make this particular equation equal to 0. And in this x plus 2 case, if x were negative 2, that would be equal to 0. So I've got 2 answers. This is an x to the 6 polynomial. So I'll have at most 6 answers. So that's what I'll be looking for. Now this is going to take some more room. Lovely. Now in case you forgot the quadratic formula, I've written it up at the top here. So in this particular expression, A is 1, B is negative 2, and C is 4. You might even want to write that down just so that I'll have it. A equals 1, B equals negative 2, and C is going to equal 4. And I'm going to figure out what these 2 answers are going to be here. So I'll get x equals minus b, so minus the negative 2 would be 2, plus or minus the square root of b squared, so negative 2 squared is 4, minus 4 times a, which is 1, times 4, which would be 16, all over 2 times a, so that would be all over 2. And just solving this as we've done in previous sections, I'll get 2 plus or minus the square root of negative 12 all over 2. Simplifying this, I will get 2 plus or minus, there's a negative in here, which is going to make it an I. There's a 4 inside of here, pulling it out is a 2. What's left is a 3 all over 2. So I'll get 1 plus or minus I under the square root of 3. There's two of my answers. X equals 1 plus I under the square root of 3, and x equals 1 minus I under the square root of 3. Now, since I'm writing down answers, I'll go ahead and write down from this one up here. X equals -2. I'll go ahead and write down from this one up here. X equals 2. Once again, I would love for this thing to factor, but it won't factor, so I'm going to plug it into the quadratic formula. And I will have for this one A equals 1, B equals 2, and C equals 4. I have very similar numbers to the other one, that I have -2 plus or minus the square root of B squared is going to be 4 minus 4 times A times C is going to be 16 again, all over 2 times A. So then I'll have that equals -2 plus or minus. I'm going to get square root of -12 again. Oops. All over 2. And simplifying that, I'll have the x equals -1 plus or minus I under the square root of 3. And it simplifies similar to the previous one. There's my total of 6 answers. This is an example where we're going to need factor by grouping. And I'm going to look at this group of terms and this group of terms. And I will see what's in common to just these two. And I see that both of them contain an x squared. So I'm going to factor that out, called factor by grouping. And I'll have an x plus a 2 left. Plus, I'll factor 3 out of these two. And magically, I'll have very similar. Notice how magic this is right here. See that and that. Very similar terms here. So I'm going to factor out the x plus 2. And when I factor x plus 2 out of first term, I have an x squared left, plus 3 is what I have left after factoring an x plus 2 out of second term. And this one, I see that x equal -2 is an answer. For this one, I've got a little manipulation to do, not much. X squared plus 3 equals 0. Figure out where it equals 0. X squared equals -3. Then I'm going to take the square root of both sides, remembering my plus minus case, and I will get that x equals plus minus I onto the square root of 3. So here's 2 answers, and here's my third answer. They're also going to ask you to do some absolute value problems. In these absolute value problems, it's important to remember that inside of the absolute value could either equal the positive answer, or 3x plus 2 could equal the negative answer, and just solve for both of those cases. You'll subtract 2 from both sides. 3x equals 5, and x equals 5/3 is one of your answers. The other answer is 3x equals -9. Divide both sides by 3, x equals -3. On absolute value problems, it's important to check your answers, because sometimes you get answers that won't work. If you check both of these by substituting them back in, 3 times 5/3 is 5, plus 2 is 7. The absolute value of 7 is 7. It's important to check your answers, and if you check both of them, you'll see that both of them work. Sometimes you will get answers that don't work, in which case you'll need to cross those out. I'll show you an example of that in a second. The next example involves what's called a rational exponent. I'm going to need to do the opposite of this to both sides, which means that I will want to raise both sides to the 3/2 power. When I raise both sides to the 3/2 power, the left-hand side is very sweet. It becomes x plus 2 to the first power, because 2/3 times 3 is 1. Then, if I take 9 and raise it to the 3/2 power, What that actually means is the square root of 9, which is 3, then cubed, that would be a 27. Subtracting 2 from both sides, and x is 25. You'll want to substitute that back in, make sure it checks out, and when I do, I'll have x, which is 25 plus 2 is 27. Taking the cubed root is 3, squaring it is indeed 9, so this one works. When looking at these types of equations, it's important to notice that it kind of looks like a normal quadratic. It has 3 terms, so I'm going to factor it as such. Looking at my middle term, I'll notice that square root of x times the square root of x is x. So if I let that be my individual term on each of these, I'm going to just do a little guess and say it's 3 square roots of x times 2 square roots of x. Notice that 3 square roots of x times 2 square roots of x will give me 6x, which is sitting right here. Then, in order to make a 3, I need a 1 and a 3. So I'm going to choose to put those one of these two places. I've got to figure out where that needs to go. I need to make a 7, so I think I'm going to try a minus 3 here, so that would give me a minus 9. And a plus 1 here, because minus 9 square roots of x plus 2 square roots of x is indeed minus 7 square roots of x. And then, of course, I have my minus 3. So then I'll solve each of these for 0, because I'm not finished, of course. And I'll get 3 square roots of x equals negative 1, and the square root of x equals negative 1/3, which won't work. So, because the square root of x cannot be a negative number. This one I'll get the square root of x, or 2 square roots of x, equals 3. Then I'll divide both sides by 2, and the square root of x equals 3/2. Squaring both sides in order to get rid of that square root. Oops, I wrote 3/6. I meant 3/2. Put 2 there. Making better. Squaring both sides, I will get the x equals 9/4. And then I will check that to make sure that it works. You can plug that into your calculator to check to see if it works, and if you do, you will see that it indeed works. I'm going to solve this one similar to a quadratic because it has 3 terms. I'm going to see if it will solve similar. So I'm going to get everything all on one side and order it a little more appropriately. I like 2x to the 2/3 plus 3x to the 1/3 minus 5 equals 0. Just like in the other case, I see those 3 terms and I think maybe it will factor. Looking at the middle term, I see that x to the 1/3 times x to the 1/3 would give me this x to the 2/3. So I'm going to say that I've got 2x to the 1/3 times x to the 1/3, because I do add exponents whenever I multiply. Then in order to make a 5, I need a 5 and a 1. It needs to be a plus 5 and minus 1. There's my guess. I'm going to check it. 2x to the 1/3 times x to the 1/3. Adding my 1/3 would give me 2x to the 2/3 minus 2x to these 1/3 guys plus 5x to these 1/3 guys is plus 3, and then my minus 5, so it works. But I'm not done yet, of course. So it's 2x to the 1/3 plus 5 equals 0, and x to the 1/3 minus 1 equals 0. Solving this, I'll subtract 5 from both sides and divide by 2, so that x to the 1/3 equals negative 5/2. Cubing both sides because I need to do the opposite of x to the 1/3, so I'm going to cube both sides. This is exactly what I'm doing. I will get x equals, let's see, negative 5 times negative 5 times negative 5 is negative 125/8. Then x to the 1/3 equals 1. Cubing both sides again, which is sweet to do. x equals 1. And there would be my answers. I will need to check those to see if they work, and I believe they both do. Putting them in my calculator and checking them, or checking them by hand, either way. The next example is rather messy. Anytime you have two square roots in a problem, it is very messy. The main thing is to get one square root all by itself. So I'm going to take this little guy right here, move him to the other side, and get him all by himself. And I'm going to bring the 1 over. So I have 2 onto the square root of x plus 1 minus 1 equals square root of 2x plus 3. Then I'm going to square both sides, which is going to be an utter mess because I have to square the entire side, which is messy on the left. Ridiculously messy because this is actually 2 square root x plus 1 minus 1 times itself. 2 square root of x plus 1 minus 1. Right hand side, very sweet. That's why I got him all by himself. It's just 2x plus 3. Then I've got to multiply this little thing out here, which is going to be 4 x plus 1. Then I'll have minus 2 of those things, minus 2 of those things is minus 4 of those ugly things, plus 1 equals 2x plus 3. Then what my goal is to get the square root all by himself again so I can do the whole procedure again, square both sides. So I will bring anything that doesn't have a square root on it over to the left. The square root guy is going over to the right. So going ahead and distributing because I know that I'm going to end up needing to do that. Moving that guy over, I'll have a plus 1 here, and minus 2x and minus 3, and moving the square root over. By adding into both sides, that's what I end up with so far. I know that's really stunning. I'm going to move the screen up. Alright, here we go. I've got 2 x's over here, plus 4 plus 1 is 5, minus 3 is plus 2 equals 4 onto the square root of x plus 1. Squaring both sides, yet again, it's the only way you're going to be able to get rid of 2 square roots. Sorry to say. Square and square. I'm going to end up with multiplying this thing by itself. I'll get 4x squared plus 8x plus 4 equals 16 onto x plus 1. Nice, but at least now it's solvable. I'll have 4x squared. I'm going to distribute the 16 and bring them over. So it'll be 8x minus 16x. It'll be minus 8x. Then I'll have a plus 16 here, but I'm scooting them over. So plus 4 and a minus 16 is minus 12 equals 0. Then I'm going to see, I can pull 4 out of here. It'll make it a little prettier. X squared minus 2x minus 3. Oh man, that'll factor in. That is sweet. Factoring is always nice. 4, factor this guy here. And then I get x minus 3, x plus 1. And x equals 3, or x equals minus 1. I'll need to check these, plugging them into the square roots. When you plug these guys in, you will see that this one works, and this one will not. Be sure and check them, because if you give me an extra answer, I'll have to mark off some on your problem in your quizzes or tests. So be sure and check. Now I've written out the checking here in pink so that you can see how the negative 1 won't work. The negative 1, when you try to work this problem out, you'll get negative 1 equals 1. That's not true, and that's why this x equals negative 1 won't work. Now, if you have any questions about this, be sure and post them on the discussion board or send me a message and attend to Eli.